Hi everyone, welcome to this tutorial session. In today's tutorial, we want to solve this Maths Olympiad question. We want to solve for the values of the real variables t and s in the equations root t plus root s is equal to 10 and the root of the product of t and s also equal to 10. Solve for the real values t and s. Okay, so please follow the solution from the beginning to the end because we're going to bring in very good insight and explanation to every important step that we'll use all along the way. Okay, let's start. Root t plus root s is equal to 10 and root ts is equal to 10. Okay, where t and s are real numbers. We want to solve for the values of t and s. From immediate understanding of square roots that we know square root of negative numbers do not exist. All right. Now, the square root of t plus the square root of s giving us a positive real number. The square root of the product giving us a positive real number already tells us that t must be a positive number. S must also be a positive number. Okay, because square root of negative numbers do not exist. Okay. Now, with that in mind, we will now come up with a transformation. Because if we look here, we see root t plus root s and root of their product. Let us bring a transformation that we will be able to see clearly which application that we will be able to use here. All right, let's first of all form the equations and call them equation 1 and equation 2. This first one becomes, we call this equation 1. The other one, root ts, can be written as root t multiplied to root s according to the laws of surds. We call this equation 2. These are the two equations that we have. Now, if we look clearly, working with variables that are not very common, or in this nature, variables in this nature will make our work look a bit tedious. Let's make the transformation capital X to be root t, capital Y to be root s, so that we should have simple variables to work with. So equation 1 now will become capital X plus capital Y is equal to 10. I think this is a lot simpler than working with the radical expressions. And then equation 2 will be the product of capital X and capital Y. Equation 2. Okay? This is much more easier to work with. Okay. So from here, we have many possibilities. We can use the substitution method to go ahead and solve for capital X and capital Y, as well as we can use the application of quadratic equations, because we see here x plus y, we see here xy. This is like sum of roots, this is product of roots. So if we let x and y be the roots of the quadratic equation, x squared minus sum of root multiplied to x plus product of roots equals 0. Okay, rs is just simply sum of roots. Okay, the information we have there, PR is just simply product of roots, which is the information we have there already. So this is the general form of a quadratic equation. This is method 2. You could, like I said earlier, someone can go ahead and take the substitution method of solving simultaneous equations, and you still get to the right solutions. All right, so if we use this the application of the roots of quadratic equation, we will now come in here and form this quadratic equation using these values. Okay, so that gives us the quadratic equation x squared minus 10x plus 10 is equal to 0. The roots of this quadratic equation will give us capital X and capital Y. But here we are solving in terms of small x, so no confusion. All right, so let's use the quadratic formula to solve for the values of small x. Okay, so using the quadratic formula, let's first of all collect our coefficients. The coefficient of x squared is 1, coefficient of the x is -10, and the constant term is 10. So by the quadratic formula, x is equal to minus b plus minus the root of b squared minus 4ac all over 2a. So x is equal to, let's put in a, b, c, d carefully. X is equal to minus 10 plus minus the root of minus 10 squared minus 4ac all over 2a. Okay, this gives us negative, positive. Square root -10 squared is 100. 4 times 10, 40. 2 times 1, 2. Okay, this will give us the values of small x. So we're saying small x equals 10 plus minus 100 minus 40 is 60 all over 2. Now, square root of 60, to make our work easy, to get our answer in terms of cells, we'll look for any factor of 60, which is a square number. Remember, a square number is a number whose square root is a whole number. For example, 9 is a square number because the square root of 9 is a whole number. 16 is a square number. The square root of 16 is a whole number. So, is there any factor of 60 which is a square number? Yes, we have 4. 60 is the same as 4 times 15. So, we write that as 10 plus minus the root of 4 times 15. Okay, applying the laws of sets here, we have 10 plus minus the root of 4 into the root of 15 all over 2. Root of 4 is 2. So this is 2. So we have 10 plus minus 2 root 15 all over 2. 2 is common in the numerator and the denominator. So this gives us 10 divided by 2, 5. 2 divided by itself, 2. So the roots are x equals plus minus 5 plus minus root 15. These are the values of the roots of that quadratic equation. Remember, these are the values of capital X and capital Y. So this simply means that capital X can either be 5 plus root 15 or 5 minus root 15. And capital Y can either be 5 minus root 15. If capital X is 5 plus, capital Y will be 5 minus the other value. And if capital X is 5 minus, capital Y will be 5 plus root 15. Okay, to distinguish the two. Okay, so these are the possible values of capital X and capital Y. But remember, we're not asked to find for capital X and capital Y. We're asked to find for T and S. So we're not ending there. We have to get the values of T and S. Now we remember that capital X was root T. Okay, and this is, we have two possible values here. So this simply means that T will be the square of this. Okay, T is either 5 plus root 15 square or 5 minus root 15 square. Also, capital Y is root S. Capital Y has two values. We have 5 minus root 15 or 5 plus root 15. So this simply means that S will be 5 plus 5 minus root 15 all squared, or 5 plus root 15 all squared. This gives us the values of S and T. So can we now check? So it's important to verify, to be sure that what we have is actually the solution required. So checking, let's take the left hand side of the first equation. Root t plus root s. Are we going to get 10? Now what is root t? Look at root t. Again, if root t is this one, then root s will be this one. If root t is this one, then root s will be this one. The first and the first. We take the first and the first. All right, so root t, if we have 5 plus root 15 plus 5 minus root 15. We see this gives us 5 plus 5 plus 0, which is 10. Okay, root 15 minus root 15 is 0. So the left hand side agrees with the right hand side. Okay, again, if you took the other one, if we take the second member in root t, we should also come and take the second member in root s. If we do that, we'll come up with the same result, which is 10. That's left for the learner to verify. Now, second equation, the product, root t multiplied to root s. Again, if we take the first one, let's work with the first one. The second options, the learner should be able to do that and check for him or herself. Any question, please don't hesitate to inform us on the comment section. Root t, if we take that one, we're going to have 5 plus root 15 into 5 minus root 15. 5 multiplied to 5, 25. 5 multiplied to negative root 15, negative 5 root 15. Root 15 multiplied to 5, 5 root 15. Root 15 multiplied to root 15. Root 15 multiplied to negative root 15 is negative 15. So this gives us 25. This one here is 0. 25 minus 15. Okay, which is simply 10. Okay, so now the left hand side also agrees with the right hand side, confirming therefore that the values that we got for t and s are correct.